Hello students, welcome to the session on rdbms. In our today's lecture, we will continue with the topic called parallel dbms. Okay. See, in the last section, we have seen the architecture of your parallel dbms, which is shared memory. Okay. But in our today's session, we will discuss about the shared disk systems. Shared disk system. So in this, it is very similar to your previous one, where you people will be having multiple CPUs and you people will be connected to the internet connection or as interconnection network. Okay, but here we will be not having any shared memory. Shared memory means main memory will be within your CPU only. They won't pass through all these particular shared memory, and they will be not having a common DVMS. This is what the main difference is. Now we will come to know what actually shared disk system is. Okay, I hope you people might have understood the difference between the yesterday's one and today's one. If it is not, just go through the previous video so that you will be having a clarity what is shared memory is. Now in our today's session, we will continue with the topic called shared disk system. Okay, now I'll erase this. Okay, now so while we are discussing the shared disk system, first you need to understand the architecture. See here, see the picture. Before going for the theoretical part, you people will understand by looking at this particular picture itself. See here, in the previous one, we do have a shared memory over here, which will be sharing by all the CPUs which are connected to the interconnection network. But here in this shared disk memory, we are sharing the disk in which we are storing the database. These particular disks will be shared among all the CPUs available in your network, and every CPU will be having its own individual memory. They will be not coming through the interconnection, and they will be not sharing the common memory. They will be sharing the individual memory. First CPU will be having its own memory, second CPU will be having its own memory, and third CPU will be having, fourth CPU will be having, like that. How many CPUs that you have connected in the network, every CPU will be maintained with its own individual memories, so that it will be reducing the burden onto the shared memory, which will be seen in your shared memory system. Okay, right now we will erase all these things and try to understand how do we communicate in this particular thing. Is we will be having the disk in which we will be storing the data, and it will be connected to the interconnection network, and every CPU can directly access the data whichever it want, and without any interference with the other CPUs. This is what the major advantage in your disk storage architecture. Why? Because we are not having any common internal storage or else a shared memory for which all the CPUs are requesting for. See, these requests are maintained by individual memory. As we are having individual memory, every system will be having its own memory as well as what? Its own DBMS in order to handle its queries. As it is handling the query directly, it will be requesting for the data in order to access it by the CPU. So there will be no problem in order to access the data. So the major difference here comes is, in the previous one, this shared memory will become a bottleneck when we are having number of CPUs. But even if you are using the number of CPUs in this particular architecture, it will be having its own individual memory. It will be having its own DBMS in order to maintain the queries. Okay, but just it need to go through the internet connection, and then it need to access the data. That's it. This is how your data disk architecture will be there. Shared disk architecture, I can say. Okay, and I'll erase this and see the benefits. Whatever the discussion that we had just now, they will fall under your benefits of shared disk architecture. So you will be having a it can easily load the CPU, right? It can easily load the queries, it can easily execute the queries. Why? Because it will be having its own individual memory as well as the own DBMS for each and every system, and among the CPUs it can execute them, and it will be looking for the what I'll be saying that directly it will be looking for the data from the disk. Okay, it won't look at it for a shared memory, it won't look at for the common DBMS. Why? Because every CPU is having its own software. Okay, since each CPU has its own memory, the memory bus is not a bottleneck. Means to say that it will be having its own software which can be executed on its own system itself. But here the problem comes is about your internet connection, or as the contention bottleneck will be there in your shared disk. Why? Because if you are increasing the number of CPUs which are connected to the network, then the traffic will be heavy through which you are connecting. See, if you are having 100 CPUs over here, then it is okay. If you are connecting them 1000 CPUs, then see how it will be busy in order to access those particular storage devices which have been used for storing the devices, like any disk you are using, right? Those disks will be accessed in such a manner that they are busy always. Okay, so it will become a bottleneck for them. This is the major disadvantage in your disk architecture, shared disk architecture, I can say. And apart from that, you are having one more architecture. We'll discuss them in a simple manner. The name itself, it is nothing but what? Shared nothing architecture. What it is? Shared nothing architecture. Here we won't share anything. By the name itself, I'm saying you people, every system will be having its own rdbms, its own data disk, its own CPU, right? Every system will be having its own disk, own CPU, own DBMS software in order to handle the data. But they want to access the data from other CPUs, they will be connected through the network, where it will be making a request and where it will be giving the response in return. Okay, that can be seen in our architecture that I will show you in the figure. I will close this, just I will make it up. See here, try to observe this figure. In this figure you can see there is an internet connection, there is a connection. See why the connection is important. In order to make a communication between different CPUs which are located in different physical locations, in order to make the communication, it is mandatory that you should be in a network. Okay, and here in this particular architecture, every CPU is maintaining its own individual memory. As it is maintaining the individual memory, it will be having its own DBMS. In the same way, its CPU, this CPU, and this CPU, and this CPU. Along with that, what they are maintaining its own storage disk. Okay, own storage disk will be maintained by each and every CPU. But the communication should happen in such a manner that if this CPU needs the data which has been stored at this particular CPU, then in that particular way you people will be creating a communication in order to happen a message exchange between these particular CPUs. Okay, this is how your shared nothing system will work. SEMA, by the definition, you should understand it is sharing nothing other than your internet communication or as a interconnection network. If you are having interconnection network, then you could share the data among the CPUs with this particular architecture. Okay, and here we will be having so many advantages, disadvantages which are related to your share nothing. Okay, share nothing means we are not sharing anything. Every individual system will be having its own memory in order to handle the queries, in order to retrieve the data, in order to handle the data. So it will be easy when we are comparing with the other two architectures like shared memory and shared disk, where they have shared the disk and where they have shared the internal memory. So it will become a bottleneck for them. But in this case, we are not sharing anything. So just it needs a contention among the CPU by not sharing any resources. Therefore, a high degree of scalability will be there. Why? Because every individual system can perform their own operation without interfering the other operations, other systems which are present in your network. Okay, and the second one that I could say is, since local disk references are serviced by local disk at each CPU, the shared nothing architecture overcomes the limitation of required IO. See here, IO here stands for input output devices. Every system will be having its own devices, man. There is nothing to be shared between the system, so it can perform in a well manner where it will be giving the quick response, I can say. Okay, only queries access to the non-local disk and reserves relation pass through the network. As I already told you people, if you are having two systems which are not having the data which is not there in your disk, then you will be requesting for the other systems to look at for that particular data. If it is available, it will be giving the response. That will happen by the internet connection or as interconnection between these particular systems. Okay, that you can see as an result, as an advantage. Okay, I don't want to read all of them. You people know well, right? If you are having individual CPUs, if you are having individual memory, you people will be having a increased capacity in the performance, I can say. Okay, transformation will be high. Why? Because every system will be having its own data. If it needs some other data which is there in other systems, then only they will be going for the other systems which will be making a communication. So internet communication or else the interconnection between them also, it will not become a bottleneck for them. But the limitation here is, but the disadvantage here is, shared nothing architecture are difficult to load and balance. Why? Because if you add one more CPU, you should not add only one CPU. You should add its internal memory, you should add internal disk, you should add its IO devices. Everything need to be accessed for that particular CPU. Those should be arranged in order to add them into the network. Okay, and resources will not be utilized in a sufficient manner or else successfully, I can say. Why? Because they are not shared among the CPUs. Okay, it requires an administrator properly, where it will be dividing the data across various disks. If it is not properly dispersed among the CPUs which are connected in the network, then every CPU should be checked for every time in order to access the data from your disk. Okay, adding CPU disks to shared nothing architecture means that the data may need to be redistributed. Why? Because if we are adding one more new CPU, then it need to be shared by, it need to be having some data into the data disk. If it is not, it will be having an empty disk which will be not having anything, but we will be looking for them, where you people will be wasting some memory. Okay, it needs some extra resources, extra hardware components. Okay, high speed networks are limited in size because speed of light considerations. Okay, if you are using a LAN, MAN, WAN, whatever it is, whatever the networks that you are going to use. Okay, I don't want to read all these things, man. Just try to understand. Okay, word is, if you are having more number of CPUs and it will be having its own individual elements, these individual elements will not be utilized in a successful manner. Why? Because they are not sharing among them, right? That's it. That is one of the major difficulty that you could find. These are the two architectures which are related to your parallel architecture, and in yesterday's session we have seen shared memory architecture. Follow them. It's an important topic. While you are working outside, you people will be discussing more about it. Okay, I hope it is clear to you people. That's it for now. See you in the next one. Thank you.